For the Introduction to Epidemiology course, this is the lecture on epidemiologic study designs, and this is the first lecture segment addressing the counterfactual concept. The overall objectives for this module are that students will be able to distinguish among the analytic study designs and will be able to describe the main features of these designs. So this is a schematic that's based on a figure in your textbook that shows a variety of study designs. And the ones on the left we would call descriptive study designs. That might include a case report, a case series, or some descriptive study based on rates. You know, the incidence of pancreatic cancer, over 10 years or something. We will call any of those a descriptive studies because they're maybe describing something scientifically useful, but they're not usually comparing two groups and trying to test a cause and effect hypothesis. So on the right are the analytic study designs where we are trying to compare groups and test hypotheses. So the randomized analytic study designs might include randomized controlled trials of individuals or randomized controlled trials of groups. And then on the far right, the non-randomized studies might include non-randomized interventions or observational studies. And really, in my way of thinking, observational studies are the purview of epidemiology. So we will be talking about those four in this lecture: cohort, case control, cross-sectional, and ecologic. Actually, we're going to talk about randomized trials a little bit too, but I'll get to that. So I would say that in my way of thinking, the purview of epidemiology are these observational study designs. So another graphic that some people may find useful is this one from a different didactic article. And you might ask these questions. Did the investigator assign the exposures? So is this an intervention? Did the investigator decide? If yes, then it might be, then it becomes an experimental study. And then was there random allocation to treatment or exposure status? If yes, a randomized trial. If no, a non-randomized trial. And then on the right, if the answer to did the investigator assign the exposures, that is no, that becomes an observational study. And then if it's an observational with no comparison group, that's a descriptive study. If it does have comparisons, then that's an analytic study. These authors, Grimes and Schultz, like to use this concept of direction. So if the direction that you're studying the people is exposure followed by outcome, that's a cohort study. The direction that you're studying them is outcome followed by exposure, that's a case control study. And if you're doing both at the same time, that's a cross-sectional study. This graphic may not be completely clear to you now, but as we go through this lecture, all of these concepts and terminology will be coming back through. So I'd like to start with, in this outline, I'd like to start with the counterfactual concept. So the goals of an analytic study are going to be to test a hypothesis of cause and effect. Is an exposure a cause of the disease? Does a treatment cause better outcomes? So exposure with a directional arrow meaning time and also a directional arrow meaning cause. Does this exposure or treatment cause this outcome? If that's the study question, then that's an analytic study. So data from an analytic study are also typically used to estimate a causal parameter, that is to say a measure of the association between the exposure and disease. So a few of these causal parameters or ways of using data from an analytic study are going to pop up in this lecture, but that's not the main objective. We have an upcoming module that's going to be all about the measures of association, the odds ratios, the risk ratios, and so on, and how they're calculated. So the measure of association, though, is related to the study design and how the data were collected. So we'll be seeing some mention of these measures as we go through, but that's not the main emphasis of this module. So again, going back, the main goal of an analytic study is going to be to test a hypothesis of cause and effect. And then what would be the ideal way if you want to know about cause and effect? So if you were working in a laboratory, think about how you would ask any cause and effect question, how you would test a hypothesis. You would take a group of mice or a group of Petri plates or cultures or whatever it is that you're going to study, and you would take a group of them that were identical as possible, and you would randomize them to be exposed to whatever your chemical of interest is, and others to be not exposed. And so by choosing those identical observations and conducting this experiment, you would control for potential confounding in your study, and you would have experiment that you'd be able to test cause and effect by exposing and not exposing all of your little identical mice or Petri plates or whatever. So when we're studying human beings, can we do exactly that? No. First of all, we do not have a large group of identical human beings that we can conveniently randomize. We have human beings that are different from each other. So people who think about this a lot in sort of a philosophical and mathematical kind of way like to say that the ideal study of human beings would be to take a person and have them be exposed, the same study subjects and have them be exposed, and then take the same study subjects and have them be unexposed, keeping all other conditions, including time, constant. So that is not possible. You cannot hold time constant. You expose someone to one thing, and by the time you're finished doing that, time has passed, the person is older, other issues affecting their health may be different. So you never actually have that condition where you've taken exactly the same subject and exposed them to two different things, keeping time constant. But this idea that if we could do that, that would be called, people like to call that the counterfactual, because we will never be able to observe those facts. We'll never be able to observe the same person under two different conditions. So here's an example of this ideal counterfactual design. You have a population of people who smoke in 2009. You've followed them for 10 years until 2019, and you've measured their stroke incidence over that time period. And then you take exactly the same population, but now you make them non-smokers. And then you start that study in 2009, and you study them for 10 years, and you measure their stroke incidence. So if you could do that, that would be the ideal study to determine whether smoking is a cause of strokes in human beings. Okay, so unfortunately in the real world, we can only observe a subject under one exposure status, smoking or non-smoking. The other exposure status and the outcome under that exposure status is unobservable. So the ideal but unobservable comparison is termed counterfactual. So frankly, this is as much as we are going to say about this counterfactual in this course. Very popular term and popular concept among people who really like to get very esoteric and abstract with their epidemiology. I like to get sort of, practical and, what can I teach you to help you do your studies better? So knowing more about the counterfactual is something that we don't need to pursue further, I think, in this course.